Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at the concept of electrovalent or ionic bonding. An electrovalent or ionic bond is a bond that is formed as a result of the transfer of one or more electrons from an electropositive atom to an electronegative atom. The transfer of electrons from one of the bonding atoms to the other results in the formation of ions. The atom that loses electrons forms a positively charged ion that is called a cation. The atom that gains electrons forms a negatively charged ion that is called an anion. So this means that the transfer of electrons from one of the bonding atoms to the other results in the formation of ions. And not just that, the formation of these ions is accompanied by a force of attraction between these oppositely charged ions. This force of attraction between these oppositely charged ions is called electrostatic force of attraction. The electrostatic force of attraction between the cation and the anion brings them close enough and forms a bond between them. This bond that is formed as a result of electrostatic force of attraction between a cation and an anion is referred to as electrovalent or ionic bonding. There are several compounds that are formed by this kind of bonding. And examples of compounds formed by this kind of bonding include sodium chloride and magnesium fluoride. So I'm going to take them one after the other. This diagram here represents the arrangement of electrons in the sodium atom. And the electronic configuration is 281, telling us that sodium has one electron in its outermost electron shell. It is important to note that during chemical bonding, it is only the electrons in the outermost electron shell that participate. These electrons are called valence electrons. So, from this diagram, it is clear that sodium has only one valence electron. Looking at the structure of chlorine, this diagram here shows the arrangement of electrons in the chlorine atom. You can see that chlorine has 7 electrons in its outermost electron shell. In other words, chlorine has 7 valence electrons. Sodium requires 7 more electrons to obey octet rule. Chlorine, on the other hand, requires just 1 more electron in its outermost electron shell to obey octet rule. It is easier for sodium to transfer this valence electron to chlorine than to get 7 other electrons added to its outermost electron shell. So what happens is that sodium transfers its valence electron to the chlorine atom. And when it does that, it becomes sodium ion. And not just that, when it does that, the outermost electron shell is no longer going to be this, but will be this one here. Also, the electronic configuration changes and becomes 2,8, meaning that sodium ion now has 8 electrons in its outermost electron shell. When chlorine atom accepts that electron from sodium, it becomes chloride ion. and it now has 8 electrons in its outermost electron shell. So we can see that the transfer of 1 electron from sodium atom to chlorine atom results in the formation of sodium ion as well as chloride ions. Sodium ion is a cation, chloride ion is an anion. The formation of these ions leads to an electrostatic force of attraction between them. This electrostatic force of attraction between these oppositely charged ions brings them close enough and forms a bond between them. The bond between Na plus and Cl minus, which is represented by this line here, is electrovalent or ionic bonding. The second example is in the formation of magnesium fluoride. For magnesium fluoride to be formed, 1 magnesium atom is going to combine with 2 fluorine atoms. Looking at the structure for the fluorine atoms, it is clear that each fluorine atom has 7 valence electrons, that is 7 electrons in the outermost electron shell. Magnesium, on the other hand, has 2 valence electrons. Each of the fluorine atom requires just 1 more electron in its outermost shell to obey octet rule. But magnesium, on the other hand, requires 6. It is easier for magnesium to donate each of its valence electrons to each of the fluorine atoms than to get 6 other electrons in its outermost electron shell. So what happens is that this magnesium atom transfers this electron to this fluorine atom, and it also transfers this electron to this other fluorine atom here. When that happens, the outermost electron shell for magnesium will no longer be this, but this one. And it forms magnesium ion, Mg2+. And we can see that in magnesium ion, the outermost electron shell has 8 electrons. When each of the fluorine atoms receives 1 electron each from magnesium, they become fluoride ions. And each of the fluoride ions has 8 electrons in its outermost electron shell. So what does this tell us? That the transfer of electrons from magnesium to the fluorine atoms results in the formation of magnesium ion, which is positively charged and as a result is a cation, and fluoride ions, which are negatively charged and are anions. An electrostatic force of attraction will occur between the positively charged magnesium ion and the negatively charged fluoride ions, bringing them close enough to form a bond between them. This bond, which is formed as a result of electrostatic force of attraction between magnesium ion and fluoride ions, is known as electrovalent or ionic bonding. There are certain conditions that favor the formation of electrovalent bonds. The first one is the number of valence electrons. For an electrovalent bond to be formed between atoms of 2 elements, one of the bonding atoms must have 1, 2, or 3 valence electrons, while the other one must have 5, 6, or 7 valence electrons. Looking at sodium chloride, before the electron transfer, sodium atom had 1 valence electron. Chlorine atom, on the other hand, had 7. In the case of magnesium fluoride, before the electron transfer, the magnesium atom had 2 valence electrons. Each of the fluorine atoms had 7. The second one is the difference in electronegativity. Electronegativity is the ability of an atom to attract electrons to itself in the bonded state. For an electrovalent bond to be formed between atoms of two elements, the difference in electronegativity between the atoms must be at least 2.0. Let us take the case of sodium chloride as an example. Sodium has an electronegativity value of 0.9. Chlorine, on the other hand, has an electronegativity value of 3.16. When you subtract 0.9 from 3.16, the difference in electronegativity will be 2.26. The third condition that favors the formation of electrovalent bonds is low ionization energy of the element that forms a cation. Ionization energy refers to the energy that is required to remove an electron from one mole of an atom. It is a known fact that the transfer of electrons from one of the bonding atoms to the other in electrovalent bonding leads to the formation of a cation as well as an anion. For the atom that forms the cation, the energy required to remove an electron from it must be very low. The fourth one is high electron affinity of the element that forms an anion. Electron affinity is the energy that is released when an electron is added to one mole of an atom in the gaseous state. For electrovalent bonds to be formed between atoms of different elements, the atom that forms the anion must be very electronegative. In other words, the atom that forms the anion must readily accept electrons. I want to believe that this explanation of the basics of electrovalent bonding is clear. Thank you very much for viewing, and see you in the next lesson.